Another graph physics video presentation. Comments to start, and we'll see where we'll end up. Who knows? I don't know yet. Just don't. Alright, you'd be great as a horror movie character. Fine. You'd probably be great as a stunt double for Mr. Hanky. Yeah. But whatever. Fuck you. I mean, just waste people's time. And then Hasode has to join in the quotes from the movie bullshit. A man ought to arm himself if he wants to decorate his saloon with my friend. I think it should say, if he's going to. I think that's what he said. But whatever. Thanks. Anyway, then just incomprehensible gibberish from this guy, I guess. I was enlightened, shown much by God, magnetism, and more. I believe you was I watching Ken when happened where he translate or I of Horus enlightened me went. Okay, so you get the idea. Forget it. Goodbye. Just go away. Fuck you. Just too retarded. Anyway. First off, thank you for introducing me to push gravity. Yes, it's sort of interesting that they sort of hide that one, don't they? They don't say, like, well, there is this other explanation. One that has physics in it. Not made up crap. I hadn't heard about it before watching your YouTube channel, but I was wondering what keeps the force bits trapped in the electron-proton confined there. I don't know. That's, I've sort of been over the mechanism. The electrons are what looks like attracted to protons because they're hit with more external pressure and there's no reflections between them. So they move towards the proton. And the electrons create reflections between them. I've gone over this a million times. Ping pong paddles, Closer you bring the ping pong paddles together, if you have a limited number of balls bouncing between them at a constant speed, the number of impacts increases. As you move them closer and closer, there's more and more hits, and the hits all have the same amount of momentum. So you can sort of understand that this close and this close have very different pressures on the paddles, moving them apart. So the electrons are pushed away from each other and they're pushed towards the proton, and there's tension that just holds it all together. Like, you can take regular magnets and do the same thing. Even between a piece of glass, you can put magnets all with the same face up, and they'll all repel each other, and you can sort of get the idea. You push one, all the rest of them move, that kind of thing. All right. I'm sorry. There's a lot of videos. There's one's called the magnetism. You might want to watch those. I just don't know what to tell you. It's pretty easy to imagine. There's what appears to be, what ends up being an attractive force. It's push, but it's attractive in its consequence, and a repulsive force. And it just depends on how you arrange the bits, which ones are attracting and repelling. So you can sort of understand that basic concept of an atom is the positive bits are in the center and the negative bits are on the outside. So you have the obvious scenario where they repel each other, yet they're attracted to the center. So they don't really have a choice. They'll have to find a spot where the tension is even and they stay there. That kind of thing. Alright. So, bees woot. If your explanation were true, magnetism would be about twice as strong. Why about? Wouldn't it be exactly twice as strong? I don't know. As gravity. So again, just let's pretend we don't understand anything. This is an example of the belligerency. So they're just belligerently hostile to any argument that might prove them wrong and might indicate they have the wrong idea. And they'll use any bullshit to escape, having to account for their own nonsense. But I mean, this is like Feynman's comparing photons to raindrops. It just like, well, let's just pretend we don't know the physics on the micro scale is different than the macro scale. that the consequences, that in big things there's a whole bunch of empty space, a whole bunch more empty space in big things than there are in little tiny things. And if the force all interacts with just electrons and protons, well, then you can imagine for them the force is real. Each impact is a holocaust. So of course it seems that way. If two electrons could actually hit each other, right? That's like two planets hitting each other. Very dramatic event. And yet we know that in this gravitational force arena, that's a nothing event. So of course, scale is everything. All you're saying is the scale of the interaction. If I was to make an electron as big as the Earth, or the Earth as small as an electron, well, you can't, number one, do those things because they're functionally different. The Earth, you'd still have to put all the empty space still in the Earth and shrink it. You can't give it the same density as the electron because it's made of something entirely different. It's made of electrons and protons. It's like you almost shouldn't have to explain that. But clearly you have to, because they're going to throw it out there as an accusation. Like, again, they can't understand that there's zero magnetism in gravity, technically, right? I mean, in a sense, because there's no utilization of any of the polarization. It's all undone by dipoles. So basically a dipole means whatever the yin, as I said, whatever's yinning gets yanged out of existence. So there's no magnetic effect in gravity, overtly. But clearly for the electrons and protons, it's always magnetic. They can never escape their identity as a charge and the fact that they react two different ways to two different things hitting them. So for their world, okay, they don't act as dipoles, and they don't act as dipoles at great distances. So again, it's just such a wrong, it's just stupid to try to compare what's happening to an electron to what's happening to the Earth. It's almost juvenile. It's so stupid. Okay, they're two different things in two different circumstances, and one of them is actually made of the other one. So again, it's like comparing life forms and saying, why aren't there any intelligent single cells? Well, yeah, because they can't have a brain, because you need cells to make the brain out of that. You have to have a brain, cells to make a brain. Yeah, of course a cell can't. Well, they're life forms, It's like making that kind of a comparison. It's just ignorant. That's all you can say. It's too bad this asshole doesn't sign his stupid comments. All right, anyway. So, I will draw some more on the subject just to clarify, but I mean, it's a stupid comparison. But it's found to be 10 to the 40th times stronger than gravity. Yes, if you could, the Earth is 10 times the 40th bigger than an electron. I mean, it's a stupid comparison. You don't understand stupid comparison? Yeah, it's stupid. Therefore, your explanation does not work. So this is how they do physics. This is how they seriously contemplate the world, is with this little, I got you on bullshit, on semantics, on playing a stupid game and pretending electrons are the same, in exactly the same environment, functioning exactly the same way as an Earth. When you go to all this trouble to explain, no, the force is huge. Okay, to an electron. Okay, one little photon, one little quanta moves an electron a tremendous amount of distance, where it can't do anything to the Earth. I mean, it's nothing to the Earth. I mean, it's a ridiculous comparison. This of it this way. This of it this way. Okay. One side of the object is getting bombarded by radium force bits, random force bits, red and blue. That's a big object, the Earth. The other side is facing a magnet and only getting bombarded by red or blue bits. yes, it's getting them all blue at one end and mostly red at the other end. Well, again, let's understand that magnets have varying degrees of magnetism. So that's why you have these little n numbers, and it's really telling you how many of the atoms by proportion are dipoles lining up in the right way and how many are in conflict. So clearly when you reduce the temperature, then the domains will line up more consistently, and you won't undo, one part of the magnet won't be undoing what the other part is doing. So obviously this has to do with how the net segregation, what happens overall. You can't sit there and say, well, because every cell is a dipole, I'm going to presume they're all pointed in the same direction. So again, you just want to cheat the argument. If we assume that the universe contains equal number of red and blue bits at random, yes, that's what's on the outside, the very outside of any system. And as you get deeper and deeper into the matter, that is, deeper into the galaxy, and then deeper into the solar system, deeper into the relationship between the Earth and a moon, let's say, and then deeper into the crust of the Earth, that's when you get more and more the matter is closer together, and therefore polarization can really start to matter. But at a distance, polarization can't matter. That's the R cubed scenario for dipoles. The further away you get from them, the more mixed it ends up being again. And so the fact that it's a magnet disappears at a distance because the red and the blue are mixing again. Anyway, if we assume that the universe contains equal number of red and blue at random, then the pressure from one side can be no more than twice the pressure of the other side. So his argument is, again, irrelevant to the fact that magnetism only affects other magnets, right? So again, it's the pressure is about what happens to something that's sensitive to the segregation. So the other object has to be sensitive to the segregation, and you're not just multiplying pressure. You're increasing it by every single little atomic bit that you increase it. So it's not like you double it by just making one more atom. Let's say you had one atom in 10 that was polarized, and then you make two atoms in 10 that are polarized. You see how the numbers can increase. I have 100% more magnetism now. Not, it's not like how to make it better understood. You can't just count. Well, I should just draw it. You can't just count the number of dots and say that's all that it is. It's kind of like a gravity argument. You can't say, well, gravity is a weak force. Well, not if I consolidate the matter into the size of a grapefruit. It's no longer a weak force, right? I mean, I've made the force incredibly strong by making the circumference incredibly small. So by getting rid of all the empty space, I haven't just doubled the gravity. I didn't do some minor change. I did a major change to how much gravity will be experienced by something on that surface. So, this is just such a bullshit argument. The magnets aren't 100% and gravity is 0, and then you can do this thing. Gravity doesn't have, gravity isn't the same thing. Okay, because the dipoles are undoing all the segregation. Alright, so all I can do is draw it. And you either can get it or you're not going to get it. I suppose, well, I'll think for a minute and see if I can come up with some perfect way to word it. But they're the same force, but it's a completely different manifestation. So, I mean, I try to think of some kind of bullet example. But, I mean, theoretically, no bullets, okay, is what gravity is, in the sense that it's not using the segregation force at all. It's not taking advantage of the fact that you can, if you hit electrons with just one kind of energy, you'll get a constant effect, where if you mix it and allow the proton to go the opposite direction, then you've undone what you did with the electron. I mean, if the two things are attracted to each other and I move the electron this way, well, it's not going to do me any good if I move the proton this way, right? Both of them have to go this way for the collection to move in a direction. So that's the problem. One is undoing what the other is doing. Now you can understand that if you take advantage of that in the sense that you put all the electrons so there's no proton going the wrong way, you protect the electron, the proton. You put an electron in front of it, so the electron absorbs this, and this electron absorbs this, and then the proton can be moved by the two electrons. You can understand that you've more than doubled the effect, because you had no effect before. And now you'll have an effect because you're taking advantage of the polarization. Alright. I'll be back. And such. There's the pause button. Should be able to use the keyboard, but it hasn't been working. Alright, should be back. Try this first illustration. Getting to the previous comment about what holds this stuff together, so this is just sort of redoing the point that what happens is there's two kinds of reactions. So these dark things are the electrons. Let's say this is the proton, the green stuff. Then you have green, and you have proton energy, and you have electron energy. So the universe is made of an equal amount of electron and proton energy. And it goes into a system like this, and the same amount of energy comes back out, but the difference will be is that we'll be in different places. There'll be a lot of green coming out here, and a lot of blue coming out over there. And so the proportions will be changed based on how much of a dipole you create. That is, how much of a relationship between electrons and protons. Now the key factor is that any proton energy that hits an electron will leave perpendicularly. I didn't draw those perpendicular lines exactly correctly, but whatever. So it leaves. So if proton energy reflects off a proton in this direct towards an electron, it'll just leave. And likewise, no matter what direction it's in, it doesn't reflect. Keyword, doesn't reflect. And it doesn't impose any momentum. But if it's trapped between electron energy, trapped between two electrons, in a sense there could be an infinite amount of energy. As infinite as imagining the smallest amount of distance. So whatever, a Planck infinity, this, because the tinier you make the distance, the faster the stuff is moving the same speed, and so the smaller the distance, the more impacts that take place. So this, depending on how close they are to each other, can essentially create an infinite amount of what we would call energy. Energy is an interaction. And you increase the number of interactions the closer these two things get to each other. And the opposite's happening here. There's no interaction because nothing gets reflected. So these things can't communicate with each other. If electron energy hits the proton, it leaves perpendicularly. And if proton energy hits, it leaves the electron perpendicularly. So nothing could ever reflect. So there's a zero, essentially, amount of pressure that can be maintained there between electrons and protons. Now, I would argue that once in a while a random bit of blue comes in this way, gets bent perpendicularly into the electron, and then down again. It's funny, this is backwards somehow. I have to almost look at it to see what I'm trying to do. So it goes in, and it'll, if a bit of electron energy came in this way, was bent perpendicularly this way, then it would reflect off this electron, come back in, and then go out perpendicularly again. So there'd be one reflection. So theoretically, when these two things get very close to each other, there'll be a little bit of pressure that'll keep them from hitting each other. That little bit of pressure will increase. And so there's a little bit of, there's a reason why they don't just collide. And that would be the reason. That there's always going to be a little bit of energy coming in all directions, just from the fact that they're all going to make that perpendicular turn. And so as long as there's not another, if there's another electron over here, then it probably ain't going to happen. Anything going back and forth. No, anything coming from the external world and getting to them. So that's where the whole thing gets insulated over time from one thing gets insulated from another thing, gets insulated from another thing, because they start to absorb all the energy in one direction. And there's kind of quieter spaces, that attract them, but the repulsion keeps them apart. So again, it's this whole argument that the two electrons, if I put a third electron in here, you could understand this electron can't get any closer without pushing against these two electrons. And so that's what kind of bonds the atom together. So you have to understand the atom's a little more complicated than this, because there's neutrons in here, and those are electrons and protons. And so they're creating more electrons in this picture than the standard model would draw, because it would draw the neutron as a collection rather than drawing the neutron as what it is, a dipole that has an electron and a proton in it. Very close together, no doubt. Alright, so we'll go to another illustration. Just making the point that this is magnetism, these reflections. You can't have these permanent, constant reflections except between charges, individual charges. And that's what they're comparing to the force of gravity. So they're comparing the strong nuclear force, essentially, the strength of the repulsive force between protons and protons, or the strength of the repulsive force between electrons and electrons, to gravity. And even though this makes gravity, in the end, these forces, you can't make that comparison for obvious reasons, because there's no monopoles in gravity. Earth isn't a monopole, and the sun isn't a monopole. There's no reflections. For every bit that reflects, there's a bit that gets absorbed and bent. So everything's, again, for every yin, there's a yang reaction when you're dealing with a collection of dipoles that are randomly oriented. You'll just keep on doing whatever you do. It's like a how to explain the fact that it's like the wheel turning. For every motion this way, there's a motion that way. For every motion this way, there's a motion that way. So it's conservative. It doesn't go anywhere. And so that's what you start to do to magnetism when you make big objects that aren't polarized. Big objects that don't have more stuff one place than it has the other place, that doesn't segregate these electrons and protons, it'll end up doing what a wheel does. It'll just undo any motion one way, will be undone by a motion the opposite way. Yeah. I mean, I don't want to beat this horse to death and all that crap and then beat the dead horse. But I'll see if I can come up with some other analogies to make it understood how these aren't rational comparisons. You can't compare the force of magnetism, of a phenomenon of charge, with gravity, a phenomenon happening to non-polarized dipoles. It's not a fair comparison. Fair, that's a good word. It's not a fair comparison. They're different manifestations of the function. A spinning frisbee in the air is different than one not spinning. They'll do two different things. Another way to say it. Well, even the wheel argument. A spinning wheel, holding it, could make me move because there'll be a ton of friction on the axle and it'll move me. But not spinning, I won't move at all. Alright, try this from another angle. A spatial kind of argument. So they're comparing something like, let's say the Earth is down here. The Earth is a big composite thing. So it's full. You could make the simple argument. There's a ton of empty space inside the Earth because it's made of a bunch of atoms and molecules and different structures that have distance between them. And they're basically saying, let's compare the distance the elemental object moves. Okay, so let's say this is the electron and it's radiating a force, and it's going to move based on how it interacts with, say, something else. I should just put something else here to reflect. they're going to reflect on each other. So just think of all these things as having reciprocals in space. You can sort of understand that the relationship between these original light bulbs, let's just think of it as a light bulb, and then I put the light bulbs on a platform, and they're separated by a distance now. Well, you can sort of understand that now the light's being diluted by this distance between the light bulbs, right? I mean, you could sort of understand that they're automatically now less effective as a force, because of this extra distance I've placed in here. And then if I take these clumps of light bulbs and then put them at a distance from each other, now they're even less effective. So this original thing could move, say 100 times its diameter, okay, based on the interaction. Well, this thing's not going to move 100 times its diameter, okay? It's going to be much, much less, like 1/100th of its diameter, and then this will be 1/1000th of its diameter. The amount of capacity to move it is going to change because the distance you're measuring is so much bigger as a percentage. Forget that sentence. You could just get the idea that it's so much more diluted. And so it's just basically making the argument that the interaction that's happening between electrons is the elemental action, okay? L. Yeah. That's the you can't get less space. You can't make something with less space in it, less waste. So it's as little waste as possible. And as you get bigger and bigger, you got more and more empty space that you're putting between the elements, and that empty space dilutes effectiveness. And so then when you get, you just get bigger and bigger and bigger, and they're basically saying, well, why doesn't this move 100 times its diameter? Well, obviously it can't, because everything is so spread out. You can't possibly get the same effect because this is so much more area that you have to move. I mean, this is a huge amount of distance compared to this distance. So again, it's as bad as just comparing, just looking at the size of the thing and saying, I'm going to compare the energy between two electrons, they're tiny, and the Earth. It's just not a fair comparison. Just because the amount of space is so much greater in terms of the amount of space between the actual elemental things in the Earth. There's no distance inside the electron. See, I guess I'm just trying to say is that the electron isn't made of little light bulbs. There's no distance between the light bulbs. There's zero distance. And then there's more and more distance as you get bigger and bigger. You're just adding more and more and more huge amounts of space. So obviously you can't move all that greater distance. The space means greater distance. So there's 10 to the 40th difference in size. And that's why there's 10 to the 40th distance in strength. And that's the only rational way to look at it. Really. It's the only rational way to look at it. If you could make this bigger without adding any space, so if you could make a charge as big as the Earth, that is a solid charge, a 100% charge, then it would manifest as an incredible strength of its gravity. But you can't do that. Now there is some theoretical physics where they say they can turn a sun into a grape. They can condense all the matter. But that only goes so far theoretically, in my opinion. I mean, obviously neutron stars are doing something like that, but black holes would require a whole different kind of physics, because you'd have to have these pieces so close to each other that there'd be no explanation for what would you do with all the energy that's repelling them. Where you got the energy to push them that close together. Because obviously particle gravity isn't infinite gravity. So I've sort of made that point before. Maybe that's a good thing to go over. It's sort of a related subject. So yeah, let's go back to, we'll do some of that.
they're just pointing out how bad their theory is and why it goes so wrong. It's because they don't put a limit on the amount of force that can be manifested. Alright, color. Well, because I just used black. Gravity argument, such. Alright, so the standard model incorporates, let's just say in some kind of silly way, some idea of this bent space thing being a reality. That somehow, that you can analogize it to a dent in a fabric. And theoretically, there's no reason they can't just do this, forever. They could just pull this fabric down and the fabric doesn't ever break. It can just go down forever and create more gravity. Now, the mathematical, the real description of this is really just pull gravity. I mean, it's just this idea that there's a constant flow of stuff. You could analogize it to a fluid of any kind, water, whatever you want, and it, in a constant rate, just flows in. Whatever their gravitational constant is, it just flows towards the center, getting faster as it gets into a narrower space. So it's dripping into the universe, and it just flows into a drain here in the middle of an object, and it's obviously faster, close to the drain, because it's all consolidating, smaller space, more confinement, so it speeds up, and it's slower way out here because there's less urgency. It's just got more space, and that's their model of gravity. So, like I said, they can make this drain, essentially as big as they want. See, that's probably the wrong way to say it. Wrong way to describe it. They can push as much water in as they want. So there's no end to how much water they can have pouring in here. And it all has to go out the drain because everything's confined between, say, a pane of glass. So whatever water you shove in can't go somewhere else. It has to go down the drain. So you can see that they could just build up pressure on the outside and force the water to go through that drain incredibly fast. So it's it's got no theoretical limitation. Now, they impose one. I don't know why exactly, to create something called a singularity, where somehow they make the drain too small, or they do something to this infinite system to make it not possible to be infinite. But whatever, it's an infinite system. They can just make it, like I said, they can make this well theoretically as deep as they want. And they're not constrained. And the only thing that constrains them probably is the size of particles in the universe or some other thing. And so they're using some other little constraint to tell them, well, we can't make it any smaller than that. And then somehow the atomic things break down because we have the protons inside of protons, and they can't be inside of each other. Some limit, but the limit is a preposterous limit. So obviously what I'm arguing is there's only a certain amount of pressure in the universe because there's only a certain amount of this force stuff, and you can shadow some of it or all of it. Now, it's hard to shadow all of it. That is, it's hard for an object to be dense enough where any force that goes in will be absorbed as momentum, and it just can't get out. It has to do an exchange and reflect directly back the energy. And it's there's a theoretical limitation where you can only have so much pressure in this middle because you can only create so much external pressure. So if I make this thing a certain size and density, the fact is I could make it a little bit bigger and it won't change anything in terms of how much force is getting absorbed. So how much gravity something would feel over here can't change even if I make this thing bigger, because I'm already absorbing, I'm already creating a completely black shadow here. And so you can't make the shadow any blacker than black. There's black and that's it. So there's 100% shadow, and once you hit 100%, that's the end. You're done. Now, that's a lot of gravity. I mean, you can create a lot of gravity. It'd be a very powerful gravity, black hole kind of gravity, but it wouldn't be a million solar mass kind of gravity. That kind of crap. But, so, yeah, there's a huge difference between the two explanations of gravity even. And again, they don't teach any of this. They don't give you a single alternative. They teach you this crap, and they give you no, well, it might be, or it could be possible that you could have an external force, a little tiny photon force, like the cosmic background radiation, that applies a constant pressure to all the atoms and all of the baseballs and all of the earths and all of the moons and all the objects in the world, and creates what we experience, which is a constant pressure as matter. Every piece of matter is pressurized, and if you put two things in a pressurized vessel, that is where the pressure has to move in straight lines, then the straight, if it can't curve around the object and fill this space with pressure, you can see a straight line force, it has to create shadows. There's just no way it won't if it's a straight line force. And that does work, and it's called mock gravity, but they don't teach that in any high schools. They don't explain how, well, there is this alternative theory that fits the evidence really well. And yet it has a few liabilities in the sense that if you have this straight line force, you have to explain why there's no drag. But, I've already gone over the drag argument. In so many ways it's easy to illustrate, in the sense that if you understand pure kinetics, two interactions, two things hit each other, or two things miss each other, okay, they go by each other, how would you tell the difference? If they hit each other and reflected, or they missed each other, how would you tell the difference? Because the end product's going to be a thing going this way and a thing going this way. There's not going to be any difference. So how could you have drag in a system where there can't be any difference between direct collisions, and misses don't make any difference? And the only thing that changes this diagram is the fact that when you understand there's two kinds of force, then you could see the difference. If I just say that the two force bits are identifiably different, a red thing hits a green thing, well, then you're going to see the difference, because if they hit each other and reflect, it's going to look like that, and if they miss each other, it's going to look like this. So you'll see the difference in the universe. And that's another huge reason to recognize that this is what's happening. This isn't. And this is why there's charge, and electrons and protons behave in an opposite manner, is because of these simple laws of pure kinetic interactions, where you send out exactly what you got in, but you're sending it out in colors, which makes it possible for there to be a change in what's going to happen as a consequence of the two events. Nothing happens in this world, and all kinds of stuff can happen in this world. Yeah, that's pretty simple. Alright, so anyway, so their theory has no energy in it. There's no mechanism explaining what's causing this constant flow that pushes everything, it pulls everything into stuff, that it makes attraction, this ether. There's no explanation for where it is, what it does, how it functions. Nothing. They don't give you anything here, and they give you theories that have, infinities in them, that just don't have a resolution, that are paradoxical in infinities, and for some reason, they've become devoted to this functional kind of. They can't even draw it in two dimensions. They have to. The three-dimensional drawing is completely different than the two-dimensional drawing. And obviously the real universe is the three dimensions. So there's no explanation for where all this stuff goes in and where it comes out. They don't have any explanation for where the energy came from or where it goes, because they just ignore its existence, because they know it's a conservative force. That is, they know
you know, whatever energy you gain by going in, you'll have to give it back going out. And so they just ignore it. They just call it a zero system. It doesn't have any energy. Even though we know it must have energy because things are moving. The Earth moves into the sun. It's a fact. Meteors come flying in and crash. I mean, they're really moving. And they're pretending they're not. Because we're not going to explain where the energy came from. How did it get going so fast? What made it go? What made the electrons and the protons all move in a direction? And they don't explain any of it. And I can give it all to you right here. So anyway, like I said, just be belligerently ignorant. Remain belligerently ignorant. Not just ignorant by accident. You're trying to be ignorant. Okay, because you're trying to find every excuse to pretend that this silly story that you know, see, I guess that's the thing, right? You were fooled by a silly story. It's like somebody being religious or something, maybe. You know, maybe they just feel too embarrassed to admit I was duped. So they cling to it because they just don't want to admit they were fooled by such a silly story, a fairy story, a silly little gay fairy story. And they were fooled by it, and they're like embarrassed, you know. So they just can't fess up and say, okay, I get it, it's stupid. And you're doing the same thing here with physics. They clung, they grasped at straws because they wanted an answer. They wanted to resolve things. They wanted to know now. You can't wait anymore. And so they just grabbed a bad idea because it had, well, it does it. It just does it with magic. You know, yeah, okay. But at least the magic's hidden here in the three-dimensional drawing. There's no magic, you know, the magic is, you can't see the magic here. You can't see it. It's just a trick here. Because, you know, gravity helps make it so easy to see. So, you know, this explanation of gravity uses gravity to make it visible. You know, because your brain automatically thinks about going down because gravity pushes down. You know. But no, the three-dimensional drawing is where it gets silly. That's where you can see how, oh, well, that's, you might as well just say angels down it. Where's this vacuum cleaner coming from? Inside of every single atom there's a little vacuum cleaner? Come on. I can smell that shit. Alright, anyway. So, enough of a video, I think. So, till the next time. And such. Well, I really should... Yeah, there was a Ken Wheeler video. Yeah, I just don't want to make a separate video on it. But I just want to point out, he has a video where he's talking about the ether, and he says there's an experiment you can do to prove it. Right? And the experiment is you walk 40 feet away from a TV screen with a neodymium magnet, and you make a pattern on the screen. And, you know, he's basically saying that this theory that magnetism gets weaker with distance is bullshit somehow. So he's really saying Maxwell was full of shit. And he's saying somehow that no scientist has ever fallen upon this fact that there is no R cubed relationship with magnetism. It doesn't really happen that way. Magnetism doesn't fall off just like gravity by a constant rate. And that somehow, well, all the scientists have been idiots all this time, and even all the dissenters have been idiots because they somehow haven't capitalized on this fact that magnetism is much, much stronger at 30 feet than we realize. I mean, it's just so stupid. You know, and he says to us, we could do the experiment and prove it. Well, why doesn't he do the experiment and prove it? He's obviously done the experiment, so just videotape you manipulating the electrons in the CRT from 30 feet away with your magnet. Why don't you just show us you doing that? I mean, he's just so full of shit. And you're just saying, how could... And, you know, another video was 600 likes and like 35 dislikes for something that just can't be true. I mean, it just can't be. It's just too stupid. And he gets away with something that stupid. I mean, first proposing that we do the experiment he says is so simple, and yet he doesn't just do it. He has all the camera equipment. He has the video equipment. He makes videos. Why doesn't he just videotape himself doing it? If it proves not only there's an ether, but it proves that Maxwell was full of shit. And Poincaré and all the rest of his heroes were apparently full of shit because they all believe that magnetism obeys these Maxwellian rules. I mean,
And people follow that shit. The woke kind of people. I have a guru. I have a god of physics. That's all you people want. You don't want to understand physics. You just want to have a god of physics. You know, Leonard Susskind or whoever. And you don't care if he's full of shit. It's just so depressing. So anyway, now it's enough for the video. Interesting. I just don't know why that doesn't work better than that.